Health at Wageningen University, Netherlands. Her chief group conducts observational research as well as intervention studies on the role of diet and other lifestyle factors in prevention and treatment of cardiovascular diseases, gastrointestinal diseases, morbid obesity, and cancer. For more than 30 years, her research focuses on diet and cancer. She published more than 200 original scientific peer-reviewed papers and book chapters, and she is a member of the international and national advisory and scientific committees to obtain research grants from governmental and non-governmental bodies around 15 million euro and supervise more than 30 PhD students. Ellen studied nutrition and health at Wageningen University, was a visiting fellow at Boston Harvard School of Public Health, and received postdoctoral training at the Crash Hutchinson Cancer Research Center in Seattle. Professor Kampman.
Thank you very much. Thank you very much for the very kind invitation and for treating me like a queen. I feel that we came here 2 days ago and I already saw a lot of very nice places in Ankara, and also had the opportunity to meet so many very nice, interesting people, and also I'm so impressed with what you're doing here in your hospital, in the shop, in the workshops, in the lab specifically. I also saw the lab this morning, and I'm very impressed with what you all achieved. So thank you very much for having me. It's a great opportunity for me to be here. So I'm going to give 2 talks. One is sort of an appetizer for the next one. So nutrition and cancer is indeed my field of research, but I also want to show you what is now known about other risk factors. So I start with these talks: genes, lifestyle, or just bad luck. And as you of course all know, cancer is an interplay. It's not one risk factor. It's different for all different types of cancer. Each cancer is different. Even within one cancer, there's so many molecular types that they are all different, and you have to treat them differently. But also for lifestyle, each cancer has a different etiology. But it is a combination between factors. We do know that cancer regularly is a long process with all kinds of mutations, epigenetic changes in and on the DNA. Also, we hear again more than 100 different types of cancers, or all different mutations and epigenetic changes. Overall, most of the time, with starting with this first mutation in DNA, and then having a cell growth in growth-favorable environments. And this is especially, I think, where nutrition comes in. It's not so much carcinogenic compounds in nutrition, but it's more the environment that leads to more cell growth. But we see that happening in 20, 30 years. So for nutritional epidemiologists, we have to go back to the beginning and see what happened and what went on in these years, which is, of course, this is adult cancer, and most cancers are diagnosed at about 60, 65, which is of course different from where you all talked about, and that's childhood. We estimate that about 5 to 10% is really inherited, so it's really running into families. So the BRCA1 and BRCA2 genes in breast cancer, for instance, we have a very high risk, but the prevalence of such an inherited mutation luckily is not that high. We see that also in colorectal cancer, which is mainly due to lifestyle, but there are also Lynch syndrome families where the risk is very high and it occurs at an early age. This is what we estimate as epidemiologists based on the relative risks that we see for specific exposures and the prevalence of those exposures in different countries. And we say, okay, it's about 10% which is really inherited, 2% related to very high exposures in certain occupations, 20% is due to hormones, to hormone-related cancers like breast cancer and prostate cancer. It also has to do with the age at which you get your first child in breast cancer, the age difference between menarche and menopause. That's of course very important. But it might also be hormone disruptors like pesticides, which are also involved in these 20%. Then there's 1% related to pollution. That's what we now estimate, but that might be far more in the future. 20% due to chronic infections like the papilloma virus or the hepatitis virus, liver cancer, cervical cancer. 30% due to smoking, and still is, although it's declining in many countries already, it is still one of the main risk factors, and not only for lung cancer, of course, also for breast cancer and colorectal cancer. And then an unhealthy diet, low physical activity is estimated to be around 30% of the explanation of cancer. So when you add this all up, you will see that it's more than 100%. But that's of course also due to the fact that many cancers are also related to several risk factors at the same time. And these percentages differ all over the world, differ per country, per population. So if you have a high exposure to pollutants or pesticides, for instance, these numbers may, of course, change. Now, when we look at the incidence of cancer all over the world, it becomes a picture which is more of the same. When we did this 10 years or 20 years ago, you saw these huge differences in the incidence of cancer all over the world. But now, breast cancer is one of the main main types of cancer in women. Cervical cancer is going down. We also see that colorectal cancer is coming up all over the world, and not only in Western countries, but everywhere. It's now spreading. When we look at Turkey, by the way, I was, of course, preparing for this talk, and I thought, what about Turkey? What's happening there? Actually, I didn't know much about it before I came. So now I see, okay, it's lung cancer still, which is your most important type of cancer, registered at least. And then I see breast cancer and colorectal cancer as the second and third one. And these data have been collected by the WHO, the International Agency for Cancer Research in Lyon, where they get data from all cancer registries globally, and they connect them and look at these figures. So that's really interesting for an epidemiologist like myself to see what's happening. Also, what is happening in this way is that we don't need to do sometimes, we don't need to do anything, but we can just let things happen. And for instance, when people migrate from one continent to another, it's of a special interest, because what are we going to see as far as different types of tumors are concerned? And this is what we see with people who immigrated just after the Second World War. People immigrated from Japan, where they still had a very traditional lifestyle and a high incidence of stomach cancer. They migrated to the US, especially to Hawaii, where they had a more American way of living, and they also had high risk of colorectal cancer. Now, when you look at these pictures, you see that in Japan, colorectal cancer low at that time, not anymore, by the way. In the US, it was high, and the Japanese in the US, they increased very rapidly. Within 1-2 generations, they, even now, it's even higher than the people in the US. So it's increasing rapidly and shortly. And also for stomach cancer, we see completely the opposite. So there, we saw the incidence of stomach cancer among Japanese in the US declining very rapidly. Now, genes, luckily, do not change that quickly. So something else changed. What we also see, and this is causing me and many people with me a lot of concern, is that we do see still the rates of cancer increasing all over the world. But when you look at the lines, the difference in less developed versus more developed countries, you see that the line is far more steep in less developed countries. And this is something we really have to work on, and you can think, now what is happening? And of course, there's economic progress. That's for sure. That's one of the main factors, which is also attributed to all the other ones. So there's better access to health services in many countries, not for everyone, but for a majority is getting there. There's improvement of cancer registries, so also we can now see what is happening. There's an increase in life expectancy, so people are getting older, and that's why they also might get more cancer, of course. There's urbanization, and there's also, and this is where I'm coming in, an adaptation to Western lifestyles. And these are not the best lifestyles, of course. We see a transition to Western dietary habits all over the world. And especially we see that the fast foods change, of course, coming in, and we see these urge for fast foods and sugary drinks, of course, being rising very rapidly all over. We also see this in combination with a more sedentary lifestyle. So we also see that people are in traffic jams, I also saw this here, but also in offices and sitting in front of the television and eating all these fast foods. And that's what's happening. And so now I come to this estimation of these 30 to 40% of frequently occurring types of cancer. So this is the breast cancer, colorectal cancer, prostate cancer, could be avoided if we would eat more healthily and we would increase our physical activity. Now, how do we know what is important when it comes to our diet or nutrition? We can do, of course, in vitro studies where we can put one substance into test tube with cancer cells. And this is a good way to look at the underlying mechanisms. But of course, it's just one substance. It might be one nutrient or one toxin, and it might not reflect the fact how we eat. We eat in habits. We combine all this stuff together the whole time. And these are cancer cells, and normal cells may respond, of course, very differently. So it's limited, but we need it. Same thing for the animal experiments. Also quite limited in the sense that we can't feed rats and mice coffee or alcohol, or we can't let them smoke. It's different, and of course the metabolism is different as well, but we need it for underlying mechanisms. Well, the best thing we could do is, of course, RCTs, randomized controlled trials, in the same way as you do your medication trials. We'd love to do that for diet. But then people don't let themselves be fooled about what they get, a placebo or a certain diet. And also, we now know that, for instance, we did some alcohol trials in the 1980s, but now that we know that alcohol is the most carcinogenic compound in our diet, we can't get this through a medical ethical committee, of course. So we're limited in that sense. So what we're stuck with are observational studies. Observational studies, case control studies, prospective cohort studies. This is what we are usually doing. And here we have to take into account that people take everything, they combine everything. They might not remember very well what they're doing, and they do that the whole lifetime. But still we can get a finger on it. Still we are able to see differences, and we definitely see dietary patterns. But what is a problem in all observational studies is that we never know whether something is causal or not. See, we definitely changed our type of underwear over the years. And we also see global warming happening, but whether there's an association, yes, but is it causally related? That's the question, of course. Secondly, we're always dealing with a third party, it seems. So there might be what we call confounding. If you look at alcohol drinking and lung cancer, you always have to take into account that there's also smoking. And smoking is related to alcohol drinking as well as to lung cancer, and we call this a confounder. So if you don't take that into account, you can never say what is actually alcohol doing without smoking. So we have to take that into account. So these are the limitations of our studies. But if we want to say something about lifestyle and cancer, we have to put everything together. All these data from in vitro studies, animal experiments, human experiments, as well as observational studies. And then we have to do meta-analysis. We can't say anything on the basis of one study, not even on 2 or 3 studies. We need many studies, and then we can say something. Meta-analysis, and that's luckily what the World Cancer Research Fund, in collaboration with the American Institute for Cancer Research and Imperial College London, is doing with all kind of experts all over the world to look at those data and come up with evidence, scientific evidence, and come up with recommendations. And that's what they do. So in fact, there are now more than 10,000 studies. I wish there were 100,000, but it's 10,000 studies. That's already a lot of studies on nutrition and cancer that are combined with animal and in vitro research. Now, I just wanted to point this out because it's important if you want to say something about diet, nutrition, or physical activity, you have to know where this evidence is coming from. And we say that there's strong scientific evidence when you can say there's a probable association or there's a convincing association. When we call something convincing or probable, we're pretty sure there's something happening. And that needs to be at least evidence from several studies, from several types of studies, and to be convincing, there also needs to be plausible experimental evidence. So there needs to be an underlying mechanism. And it should not be able to change in the future. You don't want these lifestyle recommendations change over time, of course. Now, as an example, the World Cancer Research Fund, each number of years, they present the data on the internet or in a booklet, whatever you prefer. And you can look at those data for specific types of cancer, so not cancer overall, but really focused on different types of cancer. This is colorectal cancer. And they present an overall table. And that's really nice because here you can see the evidence right away. So you don't need to look anywhere else, this is where you have to be. And here you can see, okay, there's strong evidence, convincing or probable, for processed meat, alcohol, body fatness, and adult attained height. So those are the risk factors that we're sure of for colorectal cancer. We're also sure that physical activity is reducing the risk of colorectal cancer. Then there are some things that are probable, but still strong evidence for whole grains, foods containing dietary fiber, dairy products, and calcium supplements as protective, while red meat. And red meat is meat which looks red when you buy it, so when it's still fresh. So pork meat is also red meat. Beef, goat, lamb, horse meat, all red meat. And this red color comes from the heme iron in the red meat. And this heme iron is irritating the colorectal mucosa if you are exposed for a long time. And that might induce your risk of colorectal cancer. So that's the evidence. And from all types of cancer, the evidence is taken together, and then this is made into recommendations, lifestyle recommendations, focused on adult cancer. And so these are these recommendations at all. And when you look at the diet one specifically, it says eat a diet rich in whole grains, vegetables, fruits, and beans. They forgot the nuts, people get there. Limit consumption of fast foods, other processed foods high in fat, starches, or sugar. Limit the consumption of red and processed meat. Limit the consumption of sugar and sweetened drinks. And limit alcohol consumption if you think that's a dietary component. When you look at this, and when you look at the Turkey's lifestyle, dietary and lifestyle guidance recommendations, they're not different. So what is protecting against the most often occurring types of cancer, breast, colorectal cancer, and prostate cancer, is also what we recommend to prevent the diabetes or heart disease. So for all chronic diseases, this is it. Move more and eat a healthy diet. And we also see in many different publications focusing on breast, prostate, and colorectal cancer, we also see that when people adhere to these recommendations, there are not too many people who are able to adhere to these recommendations, but when they do, indeed, their risk of cancer is substantially lower. So, gene and lifestyle interactions, I think I wanted to make clear that lifestyle is an important factor. There might be some sort of genetic susceptibility to some environmental or lifestyle factors. For instance, you probably know these stories about a grandfather who smoked his whole life and drank whatever he did, and he went 95 and then he slept quietly and never woke up. Well, these are not very common stories, of course, but it happens. Some people are not so susceptible to smoke inhalation or to alcohol. That might happen. These are genetic differences. But so far, I don't think we will ever get to a genetically based diet. That's probably not true. We could maybe separate people in different genetic groups, but never on an individual basis in that sense. But I'm open to discussion. Next, of course, as I said, part of it is inherited, and also for people who have an inherited cancer, it may not only be the genes, but also environment might still be important. And this is what we are looking at for people with Lynch syndrome, so people with mismatch repair mutations in one of these mismatch repair genes. We're looking in the Netherlands, and it's a small country, I'm sure it is, but still, if you want to get blood samples from all over the country, it's quite happening. So we're trying to do that for all these people who have genetic mutation. And we included them in the study since 2006, and now have about 750 people. They're family members, so we have to take that into account. But we follow them up, look at their medical records, know their dietary habits, know their smoking habits, etc. Know their education. We have their blood samples, we have some fecal samples, we can look at those. And what we see And this is for colorectal adenomas, because most of the time, luckily, colon cancer does not happen that often, because the adenomas are, as a precursor lesion, are getting out before they can do something. But we see that these people who are current smokers have a 6 times higher risk of these precursors of colorectal cancer among people with a gene mutation. Well, you see that those who never smoked, that's the reference group, those who quit smoking still have a higher risk, but it's already going down, so you can do something as well. And this is what these people want to know. Can we do something now that we have an inherited high risk? We see this also for men, specifically for being overweight or obese. We see 8-fold, which is much higher than in the normal population, not normal, but in the general population. It's much higher. So also here, there's something you can do. And also diet, which is usually not that strongly associated, but you can also see there's a 2-fold higher risk for those with a healthy dietary pattern without snacks and fast foods compared to those who do not adhere to such a diet. So something can be done. So also for those, you can still call that an inherited susceptibility. But then there's this question about bad luck. Is there something like bad luck? Is there something that we can't, I think, something that we can't explain? And what cannot be explained is also, for instance, the occurrence of childhood cancer. Is it genetics? Is it the environment? During pregnancy, is something going wrong during pregnancy? Is it lifestyle of the mother? Could it be folate deficiencies or maybe even too much of folic acid? What is happening? And actually, there's hardly any evidence in the etiology of childhood cancer. And that's certainly something that we're now trying to start, but you need large numbers to be able to do that. And I also hope that that will be part of our collaboration. That would be great. So summarizing, cancer etiology is a combination, of course, that wouldn't surprise you, between genes, environment, lifestyle, and possibly bad luck. But we can also prevent especially common types of cancer by eating more healthily and being more physically active, and certainly not smoking. So thank you for your attention so far.
Thank you very much. Any questions or comments from the hall?
Yes.
Thank you for your great talk. I work as a general surgeon at Lösante Hospital, Department of Surgery. In the causes of cancer list, I want to listen your opinion about the psychological stress in the causing list. During psychological stress, there are some hormones that we know that they increase. Then can we put the role of psychological stress in the 20% hormone area, or I want to listen your opinion about psychological stress. Thank you.
Thank you very much for that very interesting question, and also a difficult question, I must say, because it's really hard to estimate psychological stress, and we know that with just questionnaires, we can hardly imagine what stress is like, and also for some people, a certain amount of stress is nothing for somebody else. But now we're sort of getting closer, because now we can measure, for instance, cortisol levels in hair samples, and now we're getting somewhere, because then you can also measure cortisol levels over a longer time period, because normally your cortisol levels are all over the place during the day. But if we could measure chronic exposure to high levels, then we're getting somewhere. So I'm really hoping that that might help. So far, just from questionnaire data, we don't see anything with major life events. So if people go through a major period like a divorce, or losing their jobs, or losing a child, that doesn't seem to increase the risk of cancer. But chronic exposure to stress may be something different. So we have to look into that. So thank you very much.
Another question. A small one from me. What do you think about ecological nutrition? What I mean, you don't need to eat mango in Turkey coming from America, for example. I mean, eat what's in your environment you grow.
Okay, yes. Yes, thank you. That's also a very interesting question. Of course, from a sustainability perspective and from a climate perspective, I would say keep everything local if that's possible. What we do see in the Netherlands is that people who are able to grow their vegetables locally and also are buying it locally are also those who are highly educated and also the ones who are aware of these issues and also have the money to pay for it because it's far more expensive. And if that would change, and if it would be available for all people in the society, then I think we should definitely go for that. Whether it's more healthy, I don't know, because it's so much associated with high education. It's also associated with high physical activity, with not smoking, with less alcohol maybe. So it's also depending on these factors, on confounding factors. So it's really difficult to say that now. But I hope we'll all go that direction for our climate. Yes.
One more question.
So thank you very much for the talk. Actually, I have seen that you divided the probable possible. But how do you fit your
once again, thank you very much for your talk. I have seen that you have divided your carcinogenicity susceptibility or the possibility of the chemicals or the things that we are exposed through the nutrition into probable possible. So how do you fit those probable possible with the IR classification? Because in the IR classification, you know that they are updating every year, and now they change to the 4 types of the classes into from the 5 stages of the classes, and alcohol is inside that, and all the preservatives and all the chemicals, the antibiotics that are inside the nutritions are not actually counted as nutritions or the food that we eat, but they are preservative or supplements or the things that are put to give more taste and so on. So I think there's also a classification for that. So how do you divide it? This one you show and that one. Thank you.
Thank you. Well, you asked 2 questions in one. I think there's a classification by IR, which is now being changed towards this system, because IR also classified the number of studies. And not only the strength of, they said the strength of the evidence is also the number of studies, but now they say, okay, we have to look into what's really evidence here. So also, what is the relative risk? How strong are these associations? That's one thing. Secondly, there's of course a difference in what they classify as nutrition and what they classify as pesticides or microplastics or other components. And so they are now also in the more ultra-processed foods, for instance. They're now working on that to make another classification for that, and they're also working on a new monograph. And they're going to publish that quite soon about ultra-processed foods and about ultra-processed foods associated with cancer. And so that's certainly something they're working on, and they're also far more working on a global idea about nutrition and also taking differences in nutritional components into account in these different countries, because it's nearly all westernized still and not so much in other countries, so that will happen as well. Yeah. Yeah.
Oh, please, go ahead.
Thank you very much for your excellent presentation. My question is the alcohol and colorectal cancer relation. As we know, alcohol causes liver disease and chronic pancreatitis. How do you explain alcohol and relation to colorectal cancer? What is mechanism?
Okay, thank you. Well, the relationship between alcohol and colorectal cancer is not that high, not that strong as it is for liver cirrhosis, for instance, but it's a different aspect. And I think with liver cancer or liver cirrhosis, it might be toxic alcohol intake in the sense that it's people who are abusing alcohol. With colorectal cancer, it seems to be more of a chronic, relatively low intake of alcohol. And so it might not be that much of as working as a carcinogen as it does for liver cancer, but more like changes in hormonal status or changes in inflammation or anything like that. Or even alcohol is also, of course, a very important energy deliverer. So it gives calories. People who drink chronically also seem to have a higher body mass index, and also it might work along that way. Not so much a carcinogen to the colonic mucosa, so that works differently in the.
My second question is about epigenetics.
Yeah.
What do you think about the role of epigenetics in cancer?
I do think that epigenetic changes have a very important role in cancer. It seems to be quite difficult to really put a finger on it. How important is it? Because it's also difficult to measure, and it might change over time, of course. It's flexible, so that makes it difficult. But I do see that, for instance, I will talk about that later, but that folate and the whole folate metabolism, the one carbon metabolism, is also very important in the carcinogenic process. That might also have to do with epigenetics, DNA methylation in this sense. But I don't know, maybe you know this far better than I do. We'll talk. Yes, thank you.
Just following the last question, Helen, thank you very much indeed for your presentation. You mentioned that the adherence to the lifestyle change is generally very low, okay, in the sense. So I'm just wondering, being the epigenetics a sort of link that we have progressively discovered between the environment and our genome, do you think that, let's say, by make a stronger link between either low penetrance or high penetrance genetic alteration in my genome would convince myself to be more adherent to the lifestyle? In other words, do you expect some changes about that, or you don't?
I don't, yeah. I'm not that positive about lifestyle changes in patients, nor in people who have a very high penetrance gene, because we also did some research showing that people who have cancer do not change their lifestyle in general, and also people who have Lynch syndrome, in our case, we saw that in focus groups and qualitative research, they tend to answer that they don't want to change. And they don't want to change because they get these frequent checkups and they think that's enough. And I want to live a healthy life because I might not live that long. So why change to something that I really don't want to do? And that's the answers that we get. So I'm not that positive about lifestyle, but I'm not a psychologist or a health behavioral person, but I think we should definitely put more effort in this, but I also think it's a political question. So it's not only the individual who needs to change, but I also think that our environments should change. So we should be able to exercise, we should be able to walk and go on a bike without being threatened by cars. We should be able to eat healthily wherever we go and see that there are only fiber-rich products instead of white bread, for instance, and that we should not be exposed the whole time. It's also very difficult for every one of us to be exposed the whole time.
Thank you.
Okay, now we can. Thank you for your.
Thank you for your presentation, Dr. Kampman. How did you explain the night shift worker genetic alterations and the cancer incidence?
How do I explain the mutation that we see in young people? Is that?
Yes. Yes.
Yeah.
If a blind man are not covalently cancer incident, like not blind man. Right?
Blind?
Night shift worker. How did you explain genetic alterations in night shift worker who have more cancer?
I don't know that word.
Night shift worker. Was it?
Oh, night shift.
Is
Oh, I'm
it
so sorry. Night shift
biological,
workers. Yes. Thank you. I'm sorry. I didn't understand. Night shift workers. Yes, we do see a higher risk among night shift workers, especially among female night shift
and also
workers.
blind men.
Yeah.
Yeah.
I can't tell you what's the reason yet, because they don't seem to be able to find it. It might be also the rhythm which is changed, and sleep also has an important, maybe have an important effect on our cancer risk. And also when you're out of your normal rhythm, it might interfere with cancer risk, but we have no actual data yet to support it, but I do think that will happen in the future. I think there are many people now working on shift work, on circadian rhythms, on sleep, and I think we're getting a step further on that, but I can't just not yet say that it's really a risk factor, but I think it will get there, yes. Thank you.
No more questions, yes. Now we can move on to the second talk, nutrition and cancer.
So, I am again talking about my most favorite topic, of course, nutrition and cancer. And when you asked me to talk, I thought I'm not an expert in childhood nutrition and cancer, or childhood cancer and nutrition, but you wanted me to talk about more than that. What I try to do, because I only have these 25 minutes, I'm going to talk with you briefly about primary prevention, but then focus on cancer survivors. What should we tell them during treatment and after treatment, as far as especially body fat and body composition is concerned, about healthy dietary patterns, and I also would like to focus with you on dietary supplements. So first, primary prevention, and I showed them already based on convincing and probable scientific evidence. These are the lifestyle guidelines, and this is true for colorectal cancer. I also showed you that. And with these lifestyles, we can lifestyle guidelines. We estimate that we could prevent about 50% of colorectal cancer. But that's so it's different for different cancers, and for a hormone-related cancer as breast cancer, we can only explain about 1/3 of breast cancer due to dietary habits or physical activity. So it's different for the different types of cancer, and that's my main message of today, I think. And it also depends on the country you're looking at, of course. For breast cancer, it's a really interesting type of cancer because we have this difference between premenopausal and postmenopausally occurring breast cancer. There seem to be also, of course, different types, estrogen responsive or not, triple negative breast cancer, and definitely there are also different risk factors. So when we look at postmenopausal breast cancer, we see that alcohol is a strong risk factor, body fatness, adult weight gain, and adults attained height again. So the taller you are, the higher your risk of breast cancer. Physical activity, body fatness in young adulthood, and lactation is reducing the risk. When we now look at premenopausal breast cancer, and of course there are not that many studies focused specifically on premenopausal breast cancer as it's not that frequent, but we see also some differences. There it's convincingly shown that it's height which is increasing the risk. So it might have to do with insulin growth factors or any other growth factors, but we are actually not completely sure why being taller is increasing the risk of breast cancer and colorectal cancer and prostate cancer, by the way, but it might also be more affluence or something like that. And I come from a country where everybody's really tall, except me, so I don't know what happened there. You see for premenopausal breast cancer also vigorous physical activity, same thing, body fatness and lactation is decreasing the risk. But body fatness in itself is decreasing the risk of premenopausal breast cancer, while it's increasing the risk of postmenopausal breast cancer. And that's not something that we want to send out that much, but still it's a difference and we have to look into that. But for instance, for prostate cancer, it seems that genes are probably far more important, or bad luck, or there's anything else, but it doesn't seem to be diet that much. We do see body fatness only be associated with advanced prostate cancer and not with the not advanced type. So that's also saying something, and it's height again. But furthermore, there's nothing that we can say to men who want to protect themselves for prostate cancer. And also not for childhood cancer, because there's definitely not enough evidence. This is the main risk factor, and I can't say that enough, and I'm sure you're all aware of it, but it increases the risk of more than 10 types of cancer. So when you look, for instance, in all over the world, you see that these are women that we could, in the dark red areas, and Turkey is in there, we could prevent about 10% of female cancers if we would lose weight. There are underlying mechanisms. There are so many studies already showing that we can actually indeed say that it's body fatness in itself, it's the adipose tissue in itself, which forms also hormones, which is inflammatory, which is also increasing insulin growth factors, etc., etc. Nowadays, we also think that might have to do something also with vitamin D or with the gut microbiota. There are many different possibilities, but there's not just one mechanism. Now we go to a healthy diet, and I just already showed you, eat a diet rich in whole grains, vegetables, fruits and beans. That's what we are now recommending. But we don't actually know what are the substances in there which are protective. In the 1990s, we thought it were antioxidants. And now we think it's a combination again, with folate also, but also especially with dietary fiber. We also see very interesting findings for dietary fiber, not only for colorectal cancer, but also now coming up for other types of cancer. What is really interesting are these new studies where they put some people on a diet and see very rapid changes in time, and within a couple of weeks in their microbiota. And we also know that certain microbiota are more common among people with cancer, so we have to look into this. And this is a study where they fed African Americans with a rural African diet and vice versa. So these people, and there was of course the question, what happens if we turn it around? And they had these rural Africans with a very low risk of colorectal cancer still, but they're increasing. They have a high dietary fiber intake, a low animal protein and fat intake, and we switched them on an African American diet with where they have a higher risk of colorectal cancer, diet low in dietary fiber, high in protein and fat. And within 14 days, these people showed completely different microbiota, and so the rural Africans looked more like African Americans as far as their microbiota diversity was concerned, and especially some types of bacteria that we know are also associated with colorectal cancer risk were more prevalent. And so this is really something that we have to look into more. People have a problem with adhering to a healthy lifestyle. We just said that, and they tend to think, okay, if we can't eat vegetables and fruits, why don't we take supplements? That's far easier. And of course, we also recommend supplements. And I don't know specifically about Turkey, but we in the Netherlands, we recommend vitamin D, for instance, for people, for women above 50, for men above 70. Don't know yet why that is, and whether that's a good thing, but it is. And folate, of course, before pregnancy, we recommend those kinds of things, but not that many supplements are recommended. And the recommendation for cancer prevention is also do not use supplements for cancer prevention. Aim to get your nutrient needs through diet alone. And this is because we really were getting a fright in the 1990s when we thought antioxidants is it. We saw that vegetables were protecting against lung cancer, especially among smokers, and we thought, is this the antioxidants? And so what happened, and a couple of trials were done, RCT, very nice because you can do that with a placebo. So we gave them people a supplement with high beta carotene, in this case in Finland, where they gave beta carotene in an amount where it nearly turned to be orange, because such a high amount is about, I think, 1 kilogram of carrots per day. It's really a lot, and they gave that to high smokers and over an extended period of time. They were planning to do that for 10 years, but they broke the code somewhere in between because they were just curious what happened. And what they saw was, this is a trial among 30,000 men, they saw that the beta-carotene group had a higher risk to be diagnosed with lung cancer than the placebo group. And that at that time it was so shocking. We thought, what's happening? And then so they finished called to the US, where they also were doing the carrot trial, and they said, quit the trial, stop, and look at your data. And they saw exactly the same thing. Same thing was seen for prostate cancer. Men with high risk prostate cancer were giving selenium and other antioxidants had a higher risk of prostate cancer after taking those supplements. So after that, the whole world was shocked, and we thought, we have to look into this. And what we saw was something that my grandmother always told me: don't eat too much of a good thing. And also here we can exaggerate things. So if you not want to be deficient, then indeed your risk of cancer is also increasing and other diseases. But you also don't want to get too much. So there's certainly a safe intake that we should adhere to. So that's something that we've learned, something about dosage. We also learned something about duration. It's not as bad, it's not that bad to take supplements just in the winter time, as we tend to do, just for a short period of time, but not chronically. So that also makes a difference. The timing is really important. In this case, these men were heavy smokers already for their whole life. So they may already have cancer cells floating around. So maybe they already had lung cancer, but it was not diagnosed yet. But with the beta-carotene on top of it, it grew faster, and so they were earlier diagnosed. Something like that might also be true. And the form is really important. These are supplements. How do you call it? A red pepper, for instance, also contains antioxidants, but also contains dietary fiber, iron, vitamin C, in very nice combinations with nice dosages which work together. And in supplements, we just tend to put everything in more than 100% above the acceptable daily intake. We don't even think about the matrix, the combination between stuff. So that's really important as well. What we also saw for folate, for instance, also already in the 1990s, we saw that also here too much of a good thing, because natural folate in cabbage, green leafy vegetables is really important, and we do see that people who are deficient have a higher risk of colorectal cancer. But if we are going to fortify foods with folic acid, the synthetic form, which works differently in the whole DNA methylation process and within the DNA synthesis, folic acid works differently, higher dosage, and we saw exactly the opposite. So we saw that people who got these supplements had a higher risk of colorectal cancer. So this brings me to diet, nutrition during and after treatment. And of course, we do see there's good news as well. Survival rates are going up nearly everywhere in the world. We're doing something good. We are doing something good towards treatment. So that's good. People are surviving. But with survival also comes other challenges for people. There are recurrences. There are comorbidities, and especially in childhood cancer, we see a lot of comorbidity at a certain point of time. Cardiovascular disease, diabetes rates are far higher than in normal cancer survivors. Sarcopenia is, of course, a great risk, loss of muscle mass. We see functional decline, also for a longer period of time, not only during chemotherapy. We see depression, people are scared of what will happen to their lives. We see fatigue, chronic fatigue, also due to the treatment possibly, and neuropathy, which may also take quite some time to get back to normal levels. So this is all influencing quality of life of people who survive. Now, when you look at the number of studies that are currently conducted, it's overwhelmingly not enough. So we see that for prevention, as I said, it's about 10,000, or now it's around 25,000, which have been conducted. But when we look at before and during and after cancer, there are only a few studies. And usually these studies are not the best studies. So quality-wise, we have to do something here as well. But you feel in your heart that good nutrition is important. And we all know that good nutrition might help to at least manage side effects, fight infections. For wound healing, it might be important, speeding up recovery, etc., etc. But there's not much evidence yet. Also, because it's really difficult, because it's depending on the type of tumor, of course. So what do we say? What is good nutrition? Depends on the type of cancer. Depends on the stage of disease. You will say something completely different to somebody who's in a palliative treatment and who will not survive, versus those who have a long time of survival and who are treated curatively. The treatment, of course, is very important. So is it chemotherapy? What kind of chemotherapy? Is it radiotherapy, surgery? Is it immunotherapy? We have the idea that it would be good to have people standing at the start of immunotherapy in their best best possible way, but how could we do that, and is that really true? People have different symptoms. Some people may not be able to swallow a healthy diet. That also makes it difficult. Mucositis is a problem. And what do patients want and what do they need? The American Cancer Society just came up with new guidelines for during and after cancer. I thought they were very American in my perspective, so they only used American studies. And I thought, well, we are also doing a lot of studies in Europe, but they didn't take them into account. They did say about the same thing, so that was good. They say we have to start with nutritional assessment and with counseling as soon as possible after diagnosis. So don't wait until they're finished their treatment, but start at diagnosis. And this is what all dietitians are probably already aware of, that that's really important. And we should look more at long-term health effects and to survival. They say avoid obesity and maintain or increase muscle mass. Have regular physical activity already from diagnosis onwards, and eat a healthy lifestyle pattern and follow the recommendations for cancer prevention. And that's where we are. If we look at these recommendations, also they say after a cancer diagnosis, follow our recommendations if you can. But let's look at being a healthy weight. Because that's, of course, something that is difficult, because people might lose weight because of the cancer, because of the treatment. Is that a good thing then or not? How could we prepare them in the best way? And of course, we should also not only look at weight, but we should also look at their body composition. We should look at what about their muscle mass, what about their muscle quality. That's, of course, crucial. And we do know that the inflammation as well as metabolic dysregulation influences protein turnover, influences the muscle strength and muscle mass and quality. So that needs to remain constant. Well, we also should be aware that with women who are treated for breast cancer, we see that the fat mass is increasing, for instance. I don't know about the childhood cancer, but I can imagine that that might also happen. So, and body composition is not only always visible from the outside. I also say I'm very lean from the inside, and this is what the guy on the right can also say. He's very lean on the inside, while he has a lot of fat on the outside. But this guy is very healthy. He doesn't have diabetes. He doesn't have any high risk factors because his fat is only at the outside. And he looks the same they both look the same in the inside, so that's a good thing. So we have to look inside the body to be able to say something. So what we could use is our CT scans, for instance, that we regularly take at diagnosis as far as colorectal cancer is concerned at an L3 level. So we see the kidneys, we see the spine, and the spine and the liver. We could see that, and we can color that now to see. Okay, now this is the blue is the subcutaneous fat, so not the bad fat. Then we have the red is the muscle. We see the green is the fat in the muscle, and that's really important. As well as the yellow, which is the fat which is surrounding the organs. Now this is an extreme case of a man who had a normal BMI. He comes in, he gets colorectal cancer treatment, and after a couple of months he looks like this. So what we see is an increase in visceral fat and the fat surrounding the organs, and what we see is an increase in fat in the muscle tissue. What we do is we have a colorectal cancer study, we call it a colon study, where we follow people in time from diagnosis onwards to about 5 to 10 years after diagnosis, or how long we have funding. We give them questionnaires, we take blood, we take fecal samples, we might take hair samples at a certain point of time, and we follow them 6 months, 1 year, 2 years, and 5 years, and we take these samples, and we see who is surviving and who is not, and the quality of life we can also see, and also measures of quality of life. So in this case, we looked at fatigue. Fatigue after 6 months of treatment, we still see it 6 months after treatment. People have severe fatigue, and it was highly associated with skeletal mass density. So the higher density, the less fat infiltration, but the lower it is, you see the fatigue prevalence coming in, and that's infiltration of fat in the muscle. So what can you do about this phenomenon? For instance, well, it takes two to tango. We always say a healthy diet and healthy physical activity, and start with that at diagnosis. And what's a high diet? What's a healthy diet? I think in most dietitian practices, people will already say it's a diet rich in protein. But that's also a challenge, because we see that more than 50% of colorectal cancer patients come in with overweight or obesity. We also see that they're gaining weight at a certain point of time, even more, maybe they lose some weight than at diagnosis or just before diagnosis. But if they have a good prognosis, they gain weight again. So we have to be careful with that, but maybe at the time of treatment. But we still don't know which type of protein, animal protein, plant-based protein, what kind of amino acids should we give. So there's still a lot to be done. And also, when should we start? Should we start a diagnosis, or should we, and before treatment? And that's also something that prehabilitation, as we call it, is really important. Should we do anything before treatment starts? And how long do we have to increase their physical activity, to increase their healthy diet, their protein, we think dietary fiber? How much time do we have to change them? So that's still work in progress. We do see that a healthy dietary pattern increases cancer survival. Cancer survival. There are more than 100 studies with more than 200,000 cancer survivors done already, showing that a healthy diet definitely increases survival in many types of cancer. And we also see that when people do adhere to these cancer prevention guidelines, we see it in many studies already, it does increase or decrease mortality among female cancer survivors, among colorectal cancer survivors, and we also see a higher quality of life of those who are able to adhere to these guidelines. But those who are able to adhere, who are they? So also here, are these people doing better? Do they have a better prognosis? Are they feeling better? Are they better coached? Are they highly educated? Do they have more money? Are they in the best hospitals? So what is happening here? So it doesn't need to be a causal relationship, of course. So we have to look into that. That's already answered. Many studies show that survivors do not adhere to a healthy lifestyle. And also childhood survivors do not adhere to a healthy lifestyle. So certainly something that they have to know. That's the start. But they also have to have the ability to be able to adhere to such a diet. Then the dietary supplements during and after treatment. Also here, we saw in animal studies that antioxidants accelerate lung cancer progression indeed in mice. We also saw it with people who had head and neck cancer. 540 patients, they got antioxidants, vitamin E, beta-carotene, high dosages during radiotherapy and 3 weeks after, and 3 years after, so for chronic exposure. They were mainly smokers, which happens with people who have head and neck cancer usually. and we see the same thing. So also here, the survival is less among those who get the supplements compared to the placebo, and this was a significant, statistically significant difference. Also, we saw in our colon study, where we follow these colorectal cancer patients, we looked at folate as well as folic acid, the synthetic form, in their blood, and we saw that higher risk for recurrence with those who had folic acid, so the synthetic form, either from fortification or from supplements in their blood. We saw 30% higher risk of recurrence. And that's certainly something we want to look into, because we don't know, is it folic acid which stimulates cancer growth, or does folic acid also interfere with folate inhibiting chemotherapy, for instance? And this is certainly something that we tend to use in colorectal cancer treatment. So we really have to look into what's happening in that. And look at toxicities. Now, vitamin D is an issue I also understand that Turkey is dealing with low levels. We see low levels at diagnosis. We see lower levels than in the general population at diagnosis. Mortality, people have low levels at diagnosis. We also see that when the tumor is out, colorectal cancer, so when the surgery is effective, we see that vitamin D levels are going up spontaneously. So without supplementation, the levels go up again. And for those who have higher levels, their risk indeed of mortality is lower. But what is happening here? And we tend to think that it might also be a chicken and an egg effect here. Is it really true that low vitamin D levels increases the risk of a tumor or recurrence? Or is it true that the tumor is causing low vitamin D levels because of vitamin D receptors on the tumors and the fact that they also use vitamin D? Could that be? So we have to look into that. For now, we say supplements during treatment only with deficiencies, if they're really deficient, and measure it, not only think it, and measure it, and in consultation with an oncologist, because we never know how these supplements may interfere with the treatment that is provided. And it's not only for nutrients like micronutrients, like antioxidants and folate, but it might also be for all kinds of other dietary supplements that people are using. And I don't know how frequent it is in Turkey, but we use a lot. Not as much as the Americans, but we do tend to use a lot already. Of course, undernutrition, people are really malnourished and having deficiencies, is of course associated with worse prognosis. It's also associated with an advanced stage, of course, and also with certain types of tumors, which are either very aggressive or people are not able to eat that well. And here I would always say, go to a dietitian. And she knows or he knows what to do, and that's definitely her or his job. And they know what to do with people who are undernourished. We do get a lot of questions from patients, and somebody asked me today, "Are you on Instagram?" And I said no, because I'm getting questions from patients the whole day, and I'm saying that maybe we could do this in a more efficient way. And get a website and answer frequently asked questions, and we do that together with the dietitians network as well as nutrition scientists. And we answer questions like, should I fast before chemotherapy? Is it safe to eat dairy products? Should I avoid fish oil supplements? Which supplements should I take? Should I use turmeric or ginger? Etc., etc., etc. All these questions we tend to try to answer based on scientific evidence. And we also have a page specifically for health professionals, also to answer their questions. Now, and then I'm going to wrap up with the future research that I think we have to do. We definitely should do more about nutrition before, so prehabilitation research, before treatment, during treatment, with all these interactions between treatment and lifestyle, and also after treatment, and look at prognosis and quality of life. We should focus far more on childhood cancer, especially also on survivors of childhood cancer. What are they doing? What do they want? Or how can we help them? Etc., etc. And we should focus more on other countries than Western countries, and definitely with lower resources, different habits, diverse population also with highly educated, low educated, and differences between the different groups are growing also in Western countries, so we have to look into that. And we have to try to change lifestyle. But as I said, it's not on the individual alone. It's also policy. It's taxes on sugary drinks. It's taxes on high fat or anything, on meat, on unhealthy foods in general, which would also help us to adhere to a healthy diet. If you are interested, we also have a course, a massive online course, which is for free on nutrition and cancer. If you're interested, so you could switch me off when you have enough, or you could just follow it in a slower pace. What I would like to leave you with is that some cancers are partly preventable by a healthy diet and physical activity. We should be very careful with saying anything about nutrition and treatment and afterwards. But we also have to think, do we really want to know? Can we change? If we ask people, do you want to change? Everybody would say, yeah, we want to change. But do you really want to change is something else. So I would like to thank my group, and we also engage every now and then in physical activity, just to be out of the office as well. This is also during COVID times, although we're close together, it seems. But I also want to thank the World Cancer Research Fund, the Dutch Cancer Society, and also the EU for funding our research. And I would like to thank you for your attendance and your listening to me.
Thank you very much. We are 8:15 minutes so far. Maybe we could have only one question. Okay, please.
Thank you for speech. I wonder, there is a in Turkish population. Sugar is a danger for cancer patients. What do you think about sugar and sweet?
Well, thank you for that question. What do I think about sugar and sweets? One of the recommendations is to avoid sugary sweets, sugary foods and drinks. Not so much because of the sugar in itself, because the sugar is not bad in itself, but it increases your calorie intake, and that's the main reason. Of course, there are also theories, concepts about sugar also increasing cell growth, especially of carcinogenic cells. But what we tend to see that it's not so much the sugar in itself, but it's the calories that people take, which is of more of a problem than the sweet things in itself.
Okay. Thank you very much.
Thank you.
Our next speaker is Professor Dr. Başak Engin. She, after graduating from Hacettepe University Faculty of Pharmacy in 1999, she received her master's degree in toxicology from the same university in 2002. Dr. Engin received her PhD from Gazi University in the field of toxicology and in the field of immunology. She received the titles of Associate Professor in 2012 and the Full Professor title in 2018. She has received many awards for her research on pteridines, European Environmental Mutagen Society Young Scientist Award in 2008, Society of Toxicology in 2010, and International Society of Pteridinology in the same year. Professor Engin, who received the Best Paper Awards, was deemed worthy of the Turkish Pharmacists Association Pharmacy Academy Incentive Award in 2013. Having the title of European Registered Toxicologist, ERT, since 2014, Professor Engin was selected as an Academy of Toxicological Sciences Fellow by the American Academy of Toxicology in 2018. Professor Engin has more than 70 international publications and 19 international book chapters, some of which are included in international databases. In addition, she edited 4 international books and took part as an executive researcher in 20 scientific research projects supported by national and international institutions and organizations. Her works have been cited in more than 2,700 international journals and books. In the global evaluation made by the European American Joint Jury at Stanford University in the US in 2021 and 2022, in a database of 100,000 top scientists, Dr. Engin was among the best 2% scientists in the world ranking in terms of annual impact with her work. Welcome, Dr. Engin.
Thank you very much. Thank you very much for the very kind presentation. I'd like to thank to the organizing committee for this very nice symposium. I hope this one will be the first one of the ongoing series of the symposium with lots of scientific talks that would bring the translational research together, basic sciences as well as the clinical sciences. As a basic researcher, today I'd like to talk about the obesity, aging, senescence, and breast cancer, which is a very unfortunate cycle, and this is very common. So obesity actually is a chronic low-grade inflammation. And when the body mass index is above 30 kilogram per meter square, everything goes a little bit worse. So when we say obesity, actually there is a high increase of the free fatty acid circulation, and also there is an increase in the glucose in the circulation. So this is connected with the type 2 diabetes, and these together go with the glycolipotoxicity. And when there is high levels of glycemia and type 2 diabetes, we see that patients have hyperinsulinemia with the insulin resistance as well as leptin resistance. These together leads to the shortening of the telomeres. And these free fatty acids actually leads to the increased oxidative stress because of the increased ceramide levels in the blood, and this is connected with the reduced life expectancy. Oxidative stress eventually leads to the binding of the reactive oxygen and nitrogen species to the DNA directly, leading to DNA damage, and this also causes the shortening of the telomeres. And also aging is known to be related with the telomere shortening. This can cause the oncogenic signaling pathway start. So why obesity is a low-grade inflammation? Actually, the hypertrophic adipocytes start to release free fatty acids into the circulation. And these free fatty acids bind to the inflammatory type of M1 macrophages, toll-like receptor 4, and this starts the signaling of the inhibitor kappa B pathway, leading to the nuclear factor kappa B activation in the nucleus. Because of the transcription of these pro-inflammatory cytokines like TNF-alpha that binds to the hypertrophic adipocytes, TNF-alpha receptors, leading to the activation of the inhibitor kappa B pathway. And also the released interleukin-1 beta, as well as the osteopontin coming from the macrophages, supports this signaling pathway. And this pathway blocks the insulin receptor substrate, and so that the insulin in circulation cannot stimulate the insulin receptor anymore, leading to the chronic hyperinsulinemia and the insulin resistance. And oxidative stress, as well as the SOX pathway, supports this circulation. So from 195 countries, around 67 million individuals were assessed, and it was found that there was a causal relationship between the body mass index increase and the cancer incidence. So, as we have already seen from our previous talk by Dr. Campbell, the breast cancer is the second leading cause of cancer mortality among women, and especially in postmenopausal women. And around 15% of these patients with the breast cancer sadly develop metastatic disease, and 90% of them die. And every 5 kilogram per meter square increase in the body mass index, increase in the postmenopausal stage of the people with the breast cancer, increases 12%. So after the diagnosis of this breast cancer, actual survival rates decrease, and the body mass index increase is related up to 30%. Breast cancer aggressiveness is also related with the high recurrence rates, and this is connected with the obesity. Obesity is the main risk factor in that sense in the postmenopausal woman, actually. When we search for the majority of the cancer, we have seen that telomere length is maintained by the telomerase. So in the normal cells, actually telomerase is not active, but in the cells that are going to the malignant stage, telomerase is activated. Thus, the telomere length and telomerase activity are crucial for the cancer initiation as well as the survival and the maintenance of the tumor. Both telomerase and telomere play a very critical role in the development of the cancer stages, and the cancer cells show a stable, progressive decrease of the telomere length. Not only telomerase is responsible for that, actually there is an alternative pathway for that when the cancer cells are in need of this activity. What is telomerase? It is a ribonucleic acid and a protein complex made up of 6 different kinds of proteins that come together, and 3' ends of the linear chromosomes are found in that part of the DNA, and this is the important regulator of the telomere length. It contains a single non-coding region, which is telomerase RNA, and the reverse transcriptase part. And altogether, these 6 proteins make a sheltering complex. In obese individuals, the adipocyte telomere length is a marker of obesity. So, whole adipose tissue telomere length also reflects the adipose tissue dysfunction. So, when we have the increased telomerase activity, it means that the adipocytes go to the hypertrophic states and can behave worse. Telomere attrition, which is the telomere shortening in adipose tissue, leads to the insulin resistance as well as hyperglycemia and increased oxidative stress, and these are all related with the type 2 diabetes. Independent of all the comorbidities we already said, individuals with obesity have shorter telomeres and augmented expression of the negative regulators in the sheltering complex. In that sense, the TRF1 is the negative regulator because the telomeres actually are long regions, but then they cover up and become like a pin-like structure, so they are protected from the DNA repair, actually. So they are very protected from all the repairment processes in any sense. So increased lipid peroxidation and higher oxidized proteins levels are connected with that. In the case, TRF1 is a major contributor to telomere shortening in that sense because it protects from DNA repair system. Obesity-associated dysregulation of this sheltering complex may be partially explained by this phenomenon. So this part is the telomerase reverse transcriptase, and these are the rest of the proteins that are bound to this complex when this telomerase migrates to the nucleus. So what happens in the circulation? Actually, the inflammatory type 1 and 1 macrophages start to release inflammatory cytokines when they are hypertrophic adipocytes, releasing lots of free fatty acids. And these cytokines and the free fatty acids binds to the receptors of the endothelial cells, leading to the increased oxidative stress, activation of the MAP kinase pathways, and resulting in the inflammation as well as the insulin resistance. On the other hand, actually, this causes the insulin resistance because of the insulin receptor substrate 1 phosphorylation by the phosphoinositide 3 kinase pathway and also the acetylglycerol pathway. The acetylglycerol pathway results in the increase of oxidative stress. So when we wrap up all this, lipolysis decreases, uncoupled protein response decreases, while the adiponectins are also decreases. But the free fatty acids in the circulation increases while the triglyceride synthesis decreases. On the other hand, person is still fat because of the decreased energy expenditure in case of the telomere shortening event. So, in more than 12,000 postmenopausal women with breast cancer, it has been found that the diagnosis age was around 62. And when we look for the ethnicity background, we didn't see a real difference between the ethnicity. So the invasiveness of the breast cancer mean age was around 69. So senescence, the age population with the postmenopausal state, are prone to the breast cancer, and they would surely have severely shortened telomeres, and this telomerase inhibition leads to the metastatic invasiveness. So there is, when we search for the increased levels of estrogen levels, we see that aromatase activity of the adipocytes leads to the synthesis of the estrogen, and this is an independent risk factor for the breast cancer in the postmenopausal woman. So the obese women have 35% of higher concentrations of estrogen, as well as 130% higher concentrations of estradiol. So there are lots of hormones that will promote all the genotoxic effects. Levels of estradiol are detected in breast cancer are 50 to 100% fold higher than the concentrations of these hormones in the normal obese woman. The high estradiol concentrations found in the obese breast cancer patients are substantial from endogenous sources, so that means that they are coming from hypertrophic adipocytes. So excessive oxidative stress also contributes to this phenomenon. We have seen that insulin resistance in the case of chronic hyperinsulinemia in the obesity state with the hypertrophic adipocytes, insulin-like growth factor binding protein decreases while the insulin-like growth factor 1 increases. And this activates the phosphoinositide 3 kinase, protein kinase B, and MAP kinase pathways. And these this protein phosphoinositide 3 kinase pathway helps the telomerase activity to enhance. So it helps the cells proliferate more. So this activates and binds to the estrogen receptor on the estrogen receptor positive breast cancer cells that are making chrome-like structures. So there is a very significant association between the insulin-like growth factor 1 and the estrogen receptor status of the breast cancer patients. So this is an obese adipose tissue that has increased levels of IGF-1 and also estradiol. And this estradiol is degraded by the cytochrome P53 enzymes, leading to the release of lots of catechols, and it's metabolized. And catechols ends up the increased levels of the reactive oxygen and nitrogen species that can directly bind to the DNA, leading to the DNA damage and more mutation and the proliferation of the cells into a malignant state. So DNA damage actually happens in the breast cancer cells, and when we are talking about estrogen receptor positive cells, they start to release pro-inflammatory cytokines like interleukin-6. There are 3 types of estrogen receptors. One, 36 estrogen receptor alpha, 36 is expressed on the membrane of the cells, and 46 is found in the cytosol, and 66 found in the nucleus. And they are all connected and in close correlation with each other. And when there is an increase in the estradiol metabolites, it positively correlates with the tumor size as well as the lymph node metastasis. So if you go back to our first slide, we've seen that in the aged people, they are more obese, and have chronic inflammation because of the aging process and all the morbidities, comorbidities they have, but also because they are fat. Because of the obesity, they have lower levels of adiponectin but increased insulinemia. Anti-estrogen therapy, when this postmenopausal woman have breast cancer with the estrogen receptor positivity, has high levels of leptin. So it ends up the leptin resistance because of the decreased levels of the soluble leptin receptors. So this ends in the hyperleptinemia in circulation. But leptin also stimulates the aromatase activity in the hypertrophic adipocytes. So aromatase activity also causes the increased estrogen levels, which makes a vicious cycle leading to the breast cancer mortality increase. So what we can say that estrogen actually induces the telomerase reverse transcriptase because it binds to the estrogen responsive element on the telomerase receptor. While it is bound in the reverse transcriptase of the telomerase, it starts to synthesize the mRNA and it migrates to the nucleus, making the sheltering complex altogether and starts to make up new telomere, and the telomere is not short anymore. So the insulin cancer hypothesis postulates that chronic hyperinsulinemia is associated with the decreased concentrations of IGF binding protein 1 and 2, and that leads to the increased availability of IGF-1, as we have already said. So in the chronic hyperinsulinemia, when there is insulin receptor substrate 1 blockage, IGF levels are increased, and the estradiol axis ends up in the decreased levels of sex hormone binding proteins while the estrogen is increased. And estrogen is known to be mutagenic as well as have proliferative activity for the cells, and also it stops the apoptosis process leading to the genotoxic effects and the cell survival. Because of the high aromatase activity on the hypertrophic adipocytes, estrogen is also promoted. So IGF-1 stimulates the estrogen receptors on the estrogen receptor positive breast cancer cell, which has telomerase inhibition as well as telomere shortening. According to Medline and Bayes Central, for the inception to December 2015 and relevant reviews, telomere length can be a valuable breast cancer prognostic marker. So overall, there's a trend toward an association of longer telomeres with the better outcomes. And shorter telomeres of breast cancer are associated with older breast cancer patients and higher local recurrence rates. It's a higher tumor rate. Actually, there are some controversial results for that when the patient is in the estrogen therapy or the chemotherapy. So, as well as if the telomerase activity is high at the very early stages, it readily declines to the later stages of the breast cancer progression. So there is no convincing study considering telomerase activity on postmenopausal breast cancer in the obesity. We made a setup of the cell culture experiments with the estrogen receptor positive cells. And there was an association between longer endogenous estrogen exposure, so that means that increase longer time period of the reproductive years and greater telomere length and lower telomerase activity. We treated our cells with the fulvestrant, actually, which is an anti-hormone therapy with the estrogen receptor blocker in the high glucose concentrations, and also insulin and also leptin. So we made a insulin resistant state cell system and as well as a leptin resistant cell setup. So it means that these cells look like obese people. So we have seen that by the treatment of the fulvestrant, the cell viability decreased, and also leptin helped the cells a little bit happy so that they don't die anymore, so they survive. But in the state of the insulin resistance as well as the leptin resistance, we saw that by the time passes, the cell survival decreased. But when we add estradiol into estrogen in the circulation in this system, we have seen that cells were still alive. So they didn't die as they died in the previous experiment that they don't have the estrogen. So on the other hand, leptin levels and obesity are associated with short telomere length. So there's a significant negative correlation between telomere length and leptin. So shorter telomere length is a risk factor for the increase of obesity, actually. But there is no convincing study actually for the telomere length and leptin resistance in obese people. So we decided to measure relative telomerase activity and also the telomere length of this system with the leptin resistance state and insulin resistance state. So when we treat the cells with the leptin, we have seen that the oxidative stress coefficient was a little bit decreased, so it had some antioxidant effects. But the relative telomerase activity did not change while the telomere length was shortened and the cell viability decreased. On the other hand, we have seen that when in the state of insulin resistance and leptin resistance, the oxidative stress was a little bit lower, but the cell viability increased, but the telomeres were shorter, and the relative telomerase activity was increased. When we treat the cells with the estrogen, we have seen that the relative telomerase activity was again decreased. And when we put fulvestrant into the system, we have seen that it didn't really help the cells to die. So it didn't show the effect that we expected. The cancer cells actually should have died, but we have seen the telomerase activity was a little bit lower, but the cell viability was normal like the control group. So when we check all through what fulvestrant does is the leptin actually binds to the leptin receptors, leading to the activation of the FOXO3 pathway and activate the estrogen receptors in the nucleus, and leading to the cell go to the autophagy so that the cell would be survived, but the apoptosis would not happen. So this also activates the telomerase activity, and the cell would proliferate, and the MAP kinase pathway is activated. But fulvestrant blocks the estrogen receptors on the membrane, as well as it blocks the estrogen receptors in the nucleus. But PI3K pathway activates the ACT pathway, which is the protein kinase B, and it also supports the activation of phosphorylated the telomerase reverse transcriptase. It stimulates the telomerase activity so that there will be no shortening of the telomeres. So altogether, when we look at in the obese people with the breast cancer who are treated with fulvestrant, they would have leptin resistance, hyperglycemia, insulin resistance, would have increased levels of oxidative and nitrosative stress. And this stress would stimulate and activate the NRF2 pathway, which would go to the nucleus and start the transcription of the proteins, leading to the increase in the antioxidative capacity so that all these reactive oxygen and nitrogen species would be scavenged. But this pathway, on the other hand, also stimulates the PI3K pathway, which we have already said that would activate the telomerase. So if you block this pathway with the telomerase, we should have decreased telomerase activity. But on the other hand, there is a cycle. When there is decrease in the telomerase activity, it goes back and stimulates this pathway, leading to the further activation of the reverse transcriptase. So altogether, the people with the estrogen receptor positive breast cancer and obese and at the stage of the post-menopause, they have high aromatase activity with the high estradiol, increased telomerase activity. So they would end up with the drug-resistant metastatic breast cancer with the leptin resistance, insulin resistance, and if we are treating them with the tamoxifen, we will see the same tamoxifen resistance. Actually, tamoxifen induces the leptin synthesis so that it will end up the increased leptin itself actually increases the aromatase activity as well as the estrogen synthesis. So because of that, there is a, let's say it's a triangle in between increased telomerase activity, leptin resistance, and tamoxifen, ending up in the tamoxifen resistance. So in the insulin resistance state of this hypertrophic adipocyte synthesized leptin aromatase activity increase, leading to the increased levels of the estrogen, and anti-proliferative effect actually decreases, and we have again this tamoxifen resistance because of this long-term anti-endocrine therapy. So when we come to the conclusion, in the patients who are obese and having hypertrophic adipocytes, hyperglycemia is a common thing, with the insulin resistance, increased oxidative stress, and high leptin, and they are usually aged at the senescence stage. With the post-menopause, they have critical shortened telomeres. But this shortened telomeres actually ends up because of the high leptin levels, high aromatase activity, leading to the high estrogen levels and increased telomerase activity. And that increased telomerase activity keeps the telomere length for the cell proliferation active, leading to the breast cancer cell growth. And there is a progressive decrease in the telomere length, actually. So this is a telomere paradox in postmenopausal obesity-related estrogen receptor alpha positive breast cancers. By that, I would like to thank to my colleagues, my mentor, Professor Dr. Atilla Engin and Dr. Evren Doruk Engin, and also Dr. İpek Işık for providing the pathology slides and also the genetic testings for the Erkan Yurtçu, and for you for your attention. Thank you very much.
Thank you, Dr. Engin, for your excellent speech. Are there any questions from the audience? Thank you. Thank you. Present speakers of this session a certificate of honor is a token of our appreciation. Please, Dr. Kampman, would you join us on the stage? Thank you. It's time for coffee break now. So we'll meet after the break.